So today we have nice exponential system of equation. The first equation is x to the power y equals to 1 upon y square, and the second equation is y to the power x equals to 1 upon square root of x. Now the question is to solve these two equations so as to get the value of x and y in the real plane. So this is Anmol Mishra, and now let us see the solution. How can we find the values of x and y? So first of all, take the two equations and observe them carefully. The first equation we have is x to the power y equals to 1 upon y square. Now the right hand side of this equation can be written as 1 upon y the complete square, and that is going to be equals to y to the power negative 2. So now the first equation that we have is x to the power y equals to y to the power minus 2. Okay. Now let us see the second equation, that is y to the power x equals to 1 upon square root of x. The right hand side of this equation can be written as 1 upon x to the power 1 by 2, and that is going to be equals to x to the power negative 1 upon 2. Therefore, y to the power x equals to x to the power negative 1 by 2, and this becomes our second equation. Okay. Now the first equation that we have is x to the power y equals to y to the power negative 2. So we can simply take the power of 1 upon y on both of the side. So the left hand side will turn out to be x to the power y into 1 upon y, that is going to be x to the power 1 equals to y to the power negative 2 upon y. Now look carefully that x to the power y into 1 upon y, we cancel out y. But what if y was equals to 0? We cannot factor out 0. So from the first equation, that was x to the power y equals to 1 upon y square, we can clearly say that y cannot be equals to 0 so as to define this particular equation. So here we get some numbers that are not the values for x and y. Like from the first equation we get that y cannot be equals to 0, and similarly from the second equation 1 upon square root of x is the right hand side, so x cannot be also equals to 0. So these two cases are already eliminated. Therefore x to the power y into 1 upon y, we can simply cancel out y. Okay. So now what we currently have is x equals to y to the power negative 2 upon y. So here what we have is the value of x in terms of y. So we'll put this value of x in our second equation. So the second equation is y to the power x equals to x to the power negative 1 by 2. We'll replace x as equals to y to the power negative 2 upon y. So the left hand side will turn out to be y to the power y to the power negative 2 upon y, and the right hand side will turn out to be y to the power negative 2 upon y into negative 1 upon 2, and that's going to be y to the power 1 upon y. Okay. Now carefully take this particular equation and observe it. On one of the side we have y to the power y to the power negative 2 upon y, and this thing is equals to y to the power 1 upon y, and that is going to be y to the power y to the power negative 1. Okay. Now when we have such type of equation, we can simply compare the base so as to compare the powers or the exponentials. But two cases are there. Now remember that for base equals to 0 and 1, even if the powers are different, the left hand side and right hand side would be equal, like 1 to the power 5 is equals to 1 to the power 12, 0 to the power 4 is equals to 0 to the power 13. This means bases can be equal, but still the powers can be different, but in only two cases, for 0 and 1. So 0 is already eliminated, as I told you, so as to define these two equations perfectly. So what we can take is 1. So one solution to this particular equation that we currently have is y equals to 1. Okay. Now let us see the second case, in which we have that if base is equal, the power must also be equal, and this means all the values except 0 and 1. So what we have on the left hand side is y to the power y to the power negative 2 upon y equals to y to the power negative 1. So we can simply say that y to the power y and y to the power y on both of the side, we can simply take it as a direct base. So we will directly compare negative 2 upon y equals to negative 1. And when you will simplify this particular equation, you will get y equals to 2. And here we have the second value for y, that is equals to 2. So now let us plug in y equals to 2 in this particular equation and see if the left hand side and right hand side comes equal or not. So the left hand side will turn out to be 2 to the power 2 to the power negative 2 upon 2, that's negative 1. So 2 to the power negative 1 becomes 1 upon 2, and 2 to the power 1 upon 2 means square root of 2. Okay. And on the other side we will have 2 to the power 2 to the power negative 1, that's 2 to the power 1 by 2, and that's square root of 2. Hence the left hand side and right hand side has come equal for y equals to 2. This means y equals to 2 is absolutely correct, and y equals to 1 is already correct over there. So here we have the two values for y, that is 1 and 2. Now let us find the value of x using this. So remember this particular equation, that is x equals to y to the power negative 2 upon y. For y equals to 1 we have that x equals to 1 to the power negative 2, that's 1 only. So for y equals to 1, x is also equals to 1. Now when we put y equals to 2, the value of x is going to be equals to 2 to the power negative 2 upon 2, that's 2 to the power negative 1, and that's going to be 1 upon 2. So here we get the value of x as equals to 1 by 2 for y equals to 2. So the final set of solution for x and y which satisfy this two exponential equation is 1, 1 and 2, 1 upon 2, and that's the answer that we were looking for.